Okay, so uh, firstly, I want to know, have you covered something about pre-calculus? Because this session is going to, especially in pre-calculus. So, have you covered something? Okay. Okay. So, have you knowledge about the very small concept? You can say function. What is the function, and how we define a function? What is the limit, continuity, differentiability? Do you know about these concepts? Some. Okay. No issue. So, uh, I'm going to share my screen first. So please let me confirm whether my screen is visible or not. Okay. Okay. So the screen is visible to you. Okay. So before going towards the topic, I want to share something about the AP pre-calculus, why we are studying, and what is the relevancy. We will cover a lot of things in this AP pre-calculus. So why we are studying and what kind of weightage of every topic. Like I hope you are aware about the exam pattern and questions, what kind of questions and the weightage will be asked in your exam, right? So, if you will ask from me, what is the advantage of the pre-calculus or like functions? So here there are uh, two kind of sections in your exam. There will be two kind of sections. First is MCQs, multiple choice question. So here the part is no calculator is permitted, means there will be number of questions is 28 and the exam weight is 43.75%, right? And the time will be 80 minutes. So this is all about your exam. And now in this time, maybe this is not important for you to know because just you are going to start to prepare. So this is not not at all at this time. This is important, but yeah, this is very important for you. What kind of units and what kind of topic will be in the first, second, third, and fourth unit? So in the first unit, we will learn about the general functions, non-analytic. So the weightage is, you can say 15 to 23% weightage is only and only general functions. About the polynomials and rational functions, if we talk about the 20 to 25% weightage, exponential and logarithmic functions, as you can see here, 20 to 28%, and trigonometric function at most 35% weightage of that trigonometric and polar functions. Okay. Okay, so this is all about the your uh, exam or your topics. Now, I'm going to start the first uh, unit, basically the unit one, polynomial and rational functions. So, as you said, you are little bit aware about the functions. So, may I know what is the function? Because before understanding or before going the polynomial, I have to understand what is the function. Oh, nice. That's good explanation. Okay. And what do you think about the limit? Okay. Okay. So this is your unit one. Okay. So before understanding polynomials, you told me about the function. In the function, like I have a function and I'm denoting a function f. And function is defining from a set. The set is collection of distinct kind of objects. So Suppose I am defining a function f from a set A to set B, and here you are saying there are some input values in a set A, and after applying on the input values, function is taking some values as output. So this is the functioning of a function, right? You studied these things. This is all about things you know. This is you know. Okay. So here the function is work like a machine, I can say. Very simple language. This is the machine where function is working as a machine. It is taking some input values, and corresponding to input values, it is giving you as some output values. For the example, suppose I have a function fx is equal to 2x. Here, my A set can be anything. Like I can take a set A. It has only three elements: 1, 2, 3. And the B, it has 2, sorry, it has 2, 4, and 6. So I can say my function is taking input values like 1. So corresponding to 1, it is taking 1 and giving 2 into 1 is equal to 2. Same for 2, it is giving 4. Same for 3, it is giving 6. So this is the function, right? Okay, let's go. What is the polynomial? Polynomial. Uh-huh. Okay. So very good. Yes, very good. So the general form, I can say the general form of polynomial is like, suppose I am denoting a polynomial. This is px is equal to, I need this height. Okay. So now my polynomial, I am defining a polynomial. Px is equal to some coefficient an x to the power n plus an minus 1 x to the power n minus 1 plus so on plus a1x plus a0. This can be a polynomial in general form. I can say these are the coefficients an minus 1, a1, and a0. The it it has n plus 1 number of terms. N plus 1 number of terms means, in the simple example, if I will take any example, fx is equal to x plus 2. So here, this is the form of fx is equal to a1x plus a0. Here my a1 is 1 and a2 is 2. Yes. So this is also a polynomial. Okay. Can you give a very simple example for another example of polynomial as I gave you? Mhm. Just you need to take any kind of coefficient and just uh, form the polynomial in this form only. 2x plus 5. That's great. This is also a polynomial. I am giving. I am denoting it by px. So here my coefficient is what? 2 and 5. Okay. So these are the coefficients. Okay. Are you aware about the degree? Yes. It means degree is nothing but it is the highest power of variable, highest power of x. I'm just writing highest power of x. It means if I will take an example, fx is equal to x plus 3. So here, what is the degree of, what is the power of x? This is 1. So the degree is simply 1. 1. Okay. So in the previous example, you gave that example 2x plus 5. What is the degree here? Very good, 1. Because here also the power of x is 1. In the x plus 2, here also the power is 1. Okay. Okay. So basically, we are talking about the polynomial, not only 1 degree, 2 degree, 3 degree, 4 degree, and n degree polynomial. So if I want to form another polynomial and the degree should be 2. So polynomial is looking like this. I need some coefficient like a naught, sorry, a1 x square plus a naught, that's. So here my a1 is 5. Let's suppose and a naught is 6. So my polynomial is my 2 degree polynomial is 5x square plus 6. That is clear to you? It means here the degree is 2. Okay. So as we are watching, as we are looking, here we can perform a lot of examples of any degree, right? So if I'm asking to you, can you form a degree of 5? Can you perform a 5 degree polynomial? Yes. Or you can take 2x cube plus 5x square plus anything. But the thing is, the highest power of x should be 1. So in the first term, the highest power of x is 5. In the second term, the power of x is 3. In the third term, the power is 2. And here the power is 0. You know the power is 0 here because x to the power 0 is equal to 1. So that's why I'm saying here the power of x is 0. So I'm not writing the power of x is 0. So just I am writing only 1. Okay. So we have covered the degree also. Okay. Okay. Now I'm talking about the leading coefficient. Do you know about this? What is the leading coefficient? Suppose I am giving you an example of polynomial 5x square plus 6x plus 3. Tell me the degree and leading coefficient. Very good. Leading coefficient will be 5. Degree is 2. Because the highest power of x is 2 and the coefficient of highest power is the leading coefficient. This is correct. Coefficient of highest power of x. This is the simple definition of leading coefficient. So if I will give you any polynomial, then you can easily tell me the leading coefficient. Okay. Do you know about the end behavior of any polynomial? So do you don't know? Okay, okay. I'm telling you what is the end behavior. See, any polynomial is taking some values as input and giving some output values. Yes. If a function is taking lot of values as input and it giving lot of values as output also, but after taking any point or after taking any input, function is going towards the any value. Like for example, you can easily understand by the example, fx is equal to x plus 3. This is 1-degree polynomial. Fx is defining from a set A to B. A is what? I'm just taking any set 1, 2, 3, 4, and I'm just taking B as 4, 5, 6, and 7. So the end behavior is what? What is the end point of A and what is the end point of the set A? 1 and 4, not 6. I'm asking I'm asking the end point of A. Yeah, because if you will draw the points in the number line, so this is 1, 2, 3, 4. So the end points is 1 and 4 because all these number remaining 2 and 3 are coming between 1 and 4, right? So that's why 1 and 4 are the end points. So these are the end points, or we can say end points of a set A. Okay, corresponding to value corresponding to set A, function is taking what? 4, 5, 6, 7. So what is the endpoint of V? 7 and 4 also. Yes, yeah. Okay, so this is the endpoints. Now I'm telling my function f of 1 is taking 4 and f of 7 is taking f of 4 is taking 7 because 4 is in output set, oh sorry, input set. Input set means the set A where function taking values as input. So it is taking 4 input and giving the output is 7. So it means the end behavior is what? End behavior of f is 4 and 7, you can say, because the function is taking values at the end points is 4 and 7. That's why. Okay, so let's make an example, and that is very important. So fx is equal to 2-degree polynomial, and the leading coefficient is what? 1. Degree is 2. Okay. Okay, so if my set A is 1, 2, 5, 7, 9, 11, and my set B is 1, 9, 25, 49, 81, 121. What is the end behavior? How the function behave at end points? That is called end behavior. 11 and 121. It means function is taking values at 11 is 121. Yes. So at endpoints, function taking 121, and or you can say function taking a 1 at a point 1. Okay. Are you aware about the zeros of a polynomial or zeros of a function? Mhm. how we can understand a function has a zero or not, or what is the meaning of if a function has zero. Very good. If a function has a zero at x is equal to a, it means f of a is what? Zero. Okay. So here my fx is equal to x minus 2. Then what is the zero of f? Very good. Because at x is equal to 2, my f of 2 is 2 minus 2 is equal to 0. Hence 2 is 0 of f. Okay. Just we are taking one example also. So here my another function is fx is equal to x minus 3 square. What is the 0? Yes. Why? Yes. Or we can say because the f of 3 is 0, that's why 3 is a 0. Okay. Do you understand about the multiplicity of zeros? Okay. Let's discuss the multiplicity. Multiplicity of a zero. So the multiplicity is what? The multiplicity, how many times the zeros is happening in the function. How many times means, I hope you are aware about the derivative. Yes, because in this example my fx is x minus 3 square. It means it is happening two times, means I can write this is x minus 3, x minus 3. So here 3 and 3 are zeros two times. So the multiplicity is 2. Or you can understand by the derivative also. Or very simple explanation. If f has a 0 at x is equal to a of multiplicity 5 or multiplicity n, any multiplicity n, the derivative of n minus 1 of a is not equal to 0, but fn fn sorry, let me correct, fna is equal to 0, but fna not equal to 0. As example, my previous example I am taking fx is equal to x minus 2 square. So what is the first derivative of f? D by dx of x of fx. What is the first derivative? D by dx of x minus 2 square. Are you able to calculate? Okay. So you are not aware about the derivative. Okay. Let's discuss how we will find the derivative of x minus 2 square. So d by dx of any kind of expression x minus a to the power n, it's simply the n will come as a coefficient of x minus a. It means n into x minus a, and the power will be reduced by 1. This is the derivative of that kind of form. It means the power will come in the coefficient with x minus a and reduced by 1. So here, how we will do that? The 2 will come here, the x minus 2 will be same, and the power is reduced by 1. So this is 2 minus 1. So this is 2 into x minus 2 to the power 1. Correct? This is what? D by dx of fx. Or I can write this f dash x because I am taking 1 times derivative. This is just notification. Don't confuse with that. This is notification. D by dx of fx and f dash x. Both are same things. So why I am doing derivative? Because I want to know how is the multiplicity of the zeros x is equal to 2. So my formula is saying here, you can here, if f has a 0 at x is equal to a of multiplicity n, it means fn minus 1. It means n minus 1th derivative at a is equal to 0, and fna, it means nth derivative at a non-zero. This is quite confusing for you, I can understand. But don't worry about that. Just try to understand, and we will learn some easy approach also. Just try to understand and find the second derivative. This is second derivative. Second derivative. Okay. So for finding the second derivative, d by dx of f dash x, it means I have to take derivative here also. Just I have taken derivative in this expression both sides. So according to the rules of derivative, this is f double dash x. Just I am writing here f double dash x because I am taking 2 times derivative of fx. Or here the 2 is a constant value, so it will come as coefficient, and d by dx of x minus 2, because always the coefficient will come with the constant will come as a coefficient. So this is 2, and x minus 2 derivative is 1. So you can see here my f double dash x is 0. This is not equal to 0. But if you will check f dash, what was my f dash? F dash x is equal to what? 2 times x minus 2. If you will put here x is equal to 2, then f dash 2 is equal to 2 into 2 minus 2. It means 2 into 0, it means 0. So by the definition we can understand multiplicity is like, if you know about the derivative, if you have little bit idea about the derivative, or you can do derivative of a function, then you can easily find what is the multiplicity of a zero. Or just very simple definition, simple language, simple way to find multiplicity. This is the second way you can directly find multiplicity, but this is it has some you can say drawback. It is not always applicable, so that's why I am giving you this concept also now. So this is has some drawbacks, but we will use lot of in the lot of examples we will use that. So how many times the powers of 0 are happening, basically happening. It means this is the concept of multiplicity. In this stage you can understand. Example, My previous example, fx is equal to x minus 2 square. What is my 0? Correct? Because f of 2 is equal to 0. Got it? Okay. Or what is the multiplicity? What is the power of zeros? It means what is the power of x minus 2? So that's why the multiplicity is 2. Okay. Can you tell me the multiplicity and the zeros of this function fx, this polynomial fx is equal to x minus 7 to the power 9. Tell me the zero and multiplicity. This is very, very easy. Very good. Okay, if sum of function have more than one zeros, then what you will do? X minus 2 square, x minus 3 cube. What is the zeros? Very good. And multiplicity? Now, in this case, if we have more than one zeros, then we will talk about the multiplicity corresponding to distinct zeros, like multiplicity of 2. So the what is the power of x minus 2? Mhm. Yes, it is 2. This expression. So simply we can say the multiplicity of 0 x is equal to 2 is nothing but 2. The same way, what is the multiplicity of 3? Mhm. Very good. Because the power is 3. Okay, that's great. Okay, so we covered a lot of things like degree and zeros, multiplicity, and lot of things. Like, what is the degree of that in that example? Sorry, degrees. Yeah, this example. I'm talking about this example. X minus 2 square, x minus 3 cube. What is the degree? Now, see, if we have more number of factors, or you can say we have more number of zeros, more than one zeros, then just you need to add the all the powers. This factor has power how? 2. This factor has power 3. Just 2 plus 3 is equal to 5. See, suppose I have another example. Fx is equal to x minus 1. So here the power is 1. So you are saying this is 1 degree polynomial. Yes. And here the power of zeros, because 0 is what? 1. And the power of 0 is what? 1. So that's why the multiplicity of 1 is what? Very good. 1. So this is true. This is good. But if I will try to reduce a function, like suppose I have function x square minus 5x plus 6. How is the degree? Very good. And what is the 0? That is the question. In this kind of polynomials, what you will do? Firstly, you will reduce this polynomial into the factor form. You can say you will make factor of that polynomial. So my definition is what? Of zeros of definition of zeros. My function would be equal to 0. So this x is called 0. Yes, this is the definition of the zeros of function. So if I will check, here the function is going towards the 0. If I will successful to get all the value of x or all the input of the function where the function is going to 0, then that values will be my zeros. Yes. So here the function is going to 0. It means function is equal to x square minus 5x plus 6. X square minus 5x plus 6. It should be going to 0. Now this is the polynomial, 2-degree polynomial, or you can say this is the uh, polynomial of 2 degrees. So have you any formula to get the root of the polynomial? Root of the quadratic equation. This is the quadratic equation because it has 2 degrees. X minus 2 and x minus 2. Very good. So how you will do that? How did you do? Okay, so you have used the form of this, right? This is give me x square plus a plus b into x plus ab is equal to 0. And the zeros is what? X minus a and x minus a. Have you used that form? Okay, so this is basically this is the form of a quadratic polynomial or quadratic function if a function has two zeros. The add should be the coefficient of x and the multiplication should be the constant in the polynomial. So here, why I am doing this, I want to know what is the zeros and what is the multiplicity of particular zeros. So tell me the zeros and the multiplicity of 2 and 3 also. Can you tell me the zeros of the multiplicity of 2 and 3 is nothing but just in the factor form. What is the power of x minus 2 and what is the power of x minus 3? Okay, so the 0 is 2 and 3 because function is going 0 at x is equal to 2 and x is equal to 3 only. Yes, so that's why the 0 is 2 and 3. And multiplicity is the power of x minus 2. Here in this form the power is 1 here and this is the power of 1. So multiplicity of 2 is 1 and multiplicity of 3 is also 1. Okay, so we have discussed the polynomials. Now I am going towards the rational function. So do you understand what is the rational functions? Okay, no issue. Do you know about the rational numbers? Okay, no problem. Do you know about the natural numbers? Yes. How you for counting? What kind of numbers you will take help to counting the object? Like if you have some dogs in your family, then how will you count them? This is my one dog. This is two. This is three, four. You will count like this. Yes. So these all about the natural numbers that can help to count the object. Okay. So these are the natural numbers. Do you know about the whole numbers? How my whole numbers is looking like? No, 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 no. See, my whole number is nothing but only natural number including zero as well. 0, 1, 2, 3. These are my whole numbers. And you are talking about all the it has containing all the it contain all the decimals, all the negative numbers. Uh-huh. Okay, so you was telling correct, right? Okay, sorry. That means yeah, got it. It means you are saying natural numbers including zero. Got it? Okay. What is the integers? Integer numbers. Your one observation is correct, but second not. See, in the integers, we consider all the natural numbers and all the whole numbers also. It means 0, 1, 2, 3, and lot of numbers. These are the whole numbers. And also I am keeping -1, -2, -3 and lot of negative numbers. So the collection of all the whole numbers as well as their negative numbers, this is the integer numbers. This collection is the integer numbers. Got it? And you are talking about the fractional numbers, fractions. So the collection of all the fraction is rational numbers. That is the thing I want to discover here because we are studying rational functions. So I need to clear what is the rational numbers. So do you know how the form rational numbers look like? Can you give any example of rational number? Any number that take give me any number of rational number. 1/2. Good. So by the definition of rational number, it's a very easy. I can say that any number type of p by q where q should not equal to 0. This is the type of rational number because you express 1 by 2 as form of p by 2, so that's why this is a rational number. If I will take another rational number, so this is 3 by 2. I can take this as a rational number. Yes. So this is the type of rational numbers. Now we will understand the rational polynomial. Rational polynomial. Okay. So for understanding the rational polynomial, we have studied uh, polynomials. A polynomial is type of which the px is equal to a n x to the power n, a n minus 1 x to the power n minus 1 and so on. A2x square, a1x plus a naught. For the example, I have discussed a lot of examples. X to the power 4 plus 3x plus 7. This is also polynomial. So, what is the rational number? rational polynomial, not a rational number. I'm sorry, rational number we discussed, but now we are talking about rational polynomial. So the rational polynomial is a polynomial denoted by fx is equal to px by qx, where px and qx are polynomial. Are you getting this? So basically, the rational polynomial is made by the polynomials. Yes. If I'm taking px as my previous example, x plus 2, and another qx is also a polynomial, so I can take any polynomial x minus 1 just from the rational polynomial. How the rational polynomial is looking like this. Wait, this is the fx is equal to px by qx, means x plus 2 divided by x minus 1. So this is the rational function, you can say, because it is made by the polynomials. Got it? So polynomial here, x minus 1 is also a polynomial, x plus 2 is also a polynomial. So here my fx is a rational function because it is the type of what? Px divided by qx. So now are you able to form any kind of rational function? Can you tell me another rational function? Any kind of, as you want. Very good. X plus 5 over x plus 2 or x minus 2? X minus 2. So this is also a rational function. So basically polynomial has some properties. Polynomial has some properties. You need to remember polynomial are always continuous. Polynomials are always continuous. Do you understand continuous? What is the continuous? How you will? Uh-huh. Yes, yes. Suppose I have a function and and that is the polynomial, and I'm saying this function is continuous. Then what do you understand by continuity or continuous? Oh, very good, very good, very good. It means it has no holes in its graph, correct? Because we have not discussed graph still, so we will discuss the graph also. And by the graph, you can see where the function is has any puncture point, or some has uh, somewhere function has no value, then we can say function is not continuous, correct? So if I have polynomial, then polynomial should be always continuous. Got it? It means polynomial has no as point where the function is not taking value. It means always uh, always polynomial takes any value. Okay, so here we have polynomial x plus 5 also and x minus 2 also. So I can say that x minus x plus 5 and x minus 2, these are uh, continuous function because they are polynomial. But can you say my rational function is also a continuous function? My question is, if x plus 5 and x minus 2 are continuous, then what do you think about the fx? Then fx is continuous or not? This is the question. Okay, so for understanding the continuity, I need to understand the graph of a function. Yes, let's check. Let's check. Very simple example I am starting from. Very simple example. So I am taking a polynomial. So you need to take any polynomial. Give me any polynomial of 1 degree. Px is equal to x plus 7. So as a input set, can I take real numbers? Do you understand the real numbers? Suppose I want to draw the function in the quadratic plane. This is my x-axis, this is my y-axis. Are you aware about this? If I want to draw this function in this quadratic plane, so how I will draw this? First I will see where the function is going to 0. It means where the function is cutting at x axis. Very good. X is equal to -7. My Px is equal to 0. It means P cuts at x is equal to -7. Here my x is equal to -7. And where the function is cut at y-axis. At 0. It means if at x is equal to, suppose my px is y, because I have two planes, x-axis and y-axis. So I have seen x is equal to -7 is a point where the function is cutting at x-axis. And what is the point of in y-axis where function is cutting at y-axis? So for finding the y-axis point where the function is cutting y-axis, just put x is equal to 0 and you will get y is equal to 7. So here function is cutting y is equal to 7 here. It means we can join these 2 points by a straight line, and this is the graph of my function. Got it? So this is the graph of y is equal to x plus 7. What is my input values? These are the input values. Corresponding to these input values, you are getting an output. Suppose x is equal to -7, you are getting what? 0. And x is equal to 0, what you are getting? X is equal to 0, you are getting y is equal to 0 plus 7. It means 7. So here you can see at x is equal to 0, you are getting 7. At x is equal to something, you will get some values. It means at every value of x-axis, my function is taking value on y-axis. Correct? So by looking the graph, you can say that function, sorry, px is continuous. Correct? Okay. You have taken px is equal to x plus, sorry, what was x minus 7. Okay, take another example, qx, this is equal to x. I can take this, I can draw on the quadratic plane x-axis and y-axis. So how the qx graph is looking like this in this quadratic plane? It means it can be, it is also a straight line first. Okay, where the function is cutting at x-axis, at x is equal to 0, my qx, it means q0 is equal to 0, means the qx is passing from the origin 0. So my function is looking like, I need to draw a straight line. So this is my qx. Okay, this is qx is equal to x. So here you can see at every input value in x, function is taking at output values. Yes. So the qx is what? Continuous or discontinuous? Very good. Continuous. Okay. Now I am going to give you an example of discontinuous. So the how, let's see how we will, how the discontinuous function is looking like this. Fx is equal to uh, x plus 1 when x is taking values, from 1 to 3. Got it? And also my function is taking values 3 at x is equal to 1. Can I draw this graph on this quadratic plane? So my first graph is what? Y is equal to x plus 1, and at x is equal to minus 1, function is cut x axis at where x is equal to minus 1. So here my x is equal to minus 1. It means my first graph is defined, it is going towards minus 1 to 1. So my first graph is looking like this, correct? But the condition is my function is only defined when x belongs to 1 comma 3. 1 comma 3, it means here my x is equal to 1, here this is 2, this is 3. 1, 2, 3. It means function taking 1 here and function taking 3 here. This is the function that is given by the question. Got it? So I need to remove other function because at other points my function is not defined. So I need to erase this here. Uh-oh. Oh shit. Smaller. Okay. This is actual function. I need that. Where is the my x-axis? This is okay. So see, according to requirement, according to question fx, according to the question fx, this is equal to x plus 1. So here at 1 to 3 my function is looking like this. Okay, this is the straight line. Don't think about this is a curve. This is the straight line basically. Okay, and at x is equal to 3 function is taking values what, x is equal to 1. I need to take this is open interval because at 1 I am taking 3 value. So this is 1. Here function is taking value 3. This value function is taking. This is 1. This is 3. So here if you will check continuity at x is equal to 1. What is the requirement of continuity? Limit x tending to 1 fx should equal to f of 1. This is the condition of continuity. You have studied this or not? Okay, you have not studied. It means I need to clarify first the continuity definition of continuity. Okay, forget about this. We are not discussing here because you don't know about the concept of continuity. So just try to look towards the graph. The function is defining from 1 to 3 like this straight line, and at x is equal to 1 explicitly function is taking value 3, means function is not continuous because function was less than 2 here or very near to 1, but at x is equal to 1, we can say just before 1, just reaching before 1 function is taking value 3, or after crossing 1 function is taking value 1. It means this is the value in variation, right? Function is changing value explicitly at a point. It means function is not continuous. Are you getting this? Okay, don't worry about that. If you are not getting continuity, then don't worry about that because this is also a good concept or you need to understand. So that's why actually I was supposing you are aware about the continuity, but don't worry. So we was in rational function. Rational function was type of px divided by qx. So my question was whether qx and px and qx are continuous. If px and qx are continuous, then rational number will be continuous or not. So the answer is px qx is continuous if px qx are continuous, then px divided by qx can be continuous or discontinuous. It means what? You can't say about px qx continuity, correct? For example, px is equal to 1, sorry, just take px is equal to x. This is continuous or not? Yeah, because this is a polynomial and you have polynomial are always continuous. That's why px is continuous. If I will take qx is equal to 1, this is also a polynomial. This is the polynomial because it has no x. It means here the presence of x to the power 0. So this is the polynomial. Give me 1 minute. हेलो, हाँ अभी लगा रहे पापा थोड़े टाइम. Okay, sorry for the interruption between the class. Okay, so uh, can you hear me? Okay, so my px is polynomial and qx is also polynomial. So I can say that px, qx are continuous. Continuous. Okay, can you tell me px and qx is what? X divided by 1? Then, uh, can I write x divided by 1 is equal to x? This is also a function because I am just giving you a new name hx, and hx is a rational function. So my rational function is what? X. Finally, my hx is equal to x. So this is continuous or not? Why? Because this is also a polynomial. Very good. So this is continuous. Okay. Can I form that polynomial qx upon px? This is also a polynomial. This is also a rational function, not a polynomial. Rational function. So what is the qx? The value of the qx polynomial is 1. I have taken px and qx this. So my qx is 1, my px is x. So the function is what? 1 by x. Do you know 1 by x is discontinuous function, not a continuous function. Discontinuous function. Why I'm saying this is discontinuous? Because the graph is looking like this. This is the graph. This is the graph. This is my x-axis. This is y-axis. So here you can see this is the 0, 0. This is the point of origin. Here the function is going towards the big number infinity, and here the left hand of 0, 0, 0 function is going towards the minus infinity, very negative number. It means function is not continuous at origin. So overall function is not continuous. It means function is discontinuous. Got it? Okay, so now we have completed around 1 hour, more than 1 hour. So just we are covering 2 and 3 examples, and we will bind up this class. Okay, are you going to bore? Are you enjoying this session or not? Okay, okay. So suppose this is px, x plus x minus 3 to the power 10 and x minus 11 to the power 15. Zeros, what is the zeros? And the multiplicity of 3 and 11 and the degree. So zeros is what? Very good. And multiplicity of 3 and 11? 10 and 15. Multiplicity of 3 is what? Very good. And multiplicity of 11 is 15. Very good. And the degree? So total is? Very good. This is the degree. Okay, this is the first example. So the second question is px is equal to x plus x square plus 2 and qx is x, then find the rational function. The hx is equal to px over qx. What is the function formed by PQ? Square plus 2 over x. Great. Okay. So this is the rational function. This is formed by what? P and Q. So can you tell me this is continuous or not? Okay, so you have not idea to decide whether a rational function is continuous or not. So this is also the part of our concept. We will cover the continuity of a rational function. We will cover lot of things. Degree of rational function. We will cover the zeros of complex function, rational function. We will cover the asymptotes of rational functions and lot of things, and also we will cover the end behavior of a function. So in this today's session, the summary is what we have discussed: the polynomials, 1 degree polynomials, 2 degree polynomials, 3 degree polynomials, 10 degree polynomials, or you can form any degree polynomial. Got it? And we have discussed the zeros, multiplicity of zeros, degree of polynomials, and also we discussed the little bit concept of rational functions. So uh, uh, actually I want to give you some examples to do. Okay, so you will, if you are comfortable, then are you comfortable to do that? So should I give or not? Okay, so this is the px polynomial. You can take a screenshot also, or you can just note down your copy. So px is equal to x minus 5 to the power 21 and x minus 101 to the power 51. Then you need to find zeros, you need to find degree, you need to find multiplicity of 5 and 101. And the second question is a rational function, hx is equal to x minus 3 square plus x minus 3. Find the degree, zeros, and multiplicity of 3. So these are two questions I am giving you to do. If we will meet in another session in future, then we will cover these two very very simple example also, and also we will cover some example that is asked in your exam, AP pre-calculus. Okay, so now I am going to uh, stop the session here. So I hope you